We're starting a new unit called Systems of Equations, and what systems of equations are simply two lines on the same coordinate plane. We just saw a couple of systems with parallel and perpendicular lines. We just didn't identify them as systems, but we graphed two lines on the same coordinate plane. Systems of equations can have three different types of solutions. They can have one solution. A solution to a line is an ordered pair, x value and a y value, that makes the equation true. So when a system has one solution, it's where the two lines meet. It is a point that both lines have in common, or a solution that is in common to both lines. We can also have systems with special solutions, an infinite number of solutions, or no solution, and I think those are easier to look at from a graph than to just talk about. Our essential question today is going to be identifying how many solutions a system has by looking at a graph. So we've got our first system here, and we're going to graph these on Desmos. I've got all of my equations typed in. I'm going to turn on the first two for our first system. Here's the first line, y equals 3x plus 8, and then we're going to graph that line, y equals 4. And we're looking for how many times our lines intersect. Remember, a solution is a point on the line. This point right here is a solution to the orange equation because it's on the orange line. It is not a solution to my blue equation. This point, 0, 4, is a solution to my blue equation because it's on my blue line, but it is not a solution to my orange equation. When I scroll over right here, this point where the lines intersect is on both lines. So it is a solution to both lines. So it's a solution to the system of equations. What we're going to do for our notes is sketch a little picture of what that looked like. It does not need to be real fancy or accurate. It's just a visual of what a system with one solution looks like. So our first line looked a little something like that. Our second line was horizontal, and they met at one point to give us one solution. Here's our second system. Again, I've got these typed in on Desmos for us. So we'll turn on these equations one at a time. Here's that first equation and the second equation. Notice that that green line turned orange when I graphed the second line. That's because these two equations are the same line. This point, that is a solution to my orange equation, is also a solution to my green equation. Every point that is on one of the lines is on both lines. So this is a case where we have an infinite number of solutions. Sketching what this system looked like. And to clarify that it did have two lines, I am going to graph both of them. I'm going to make my second line just a little bit shorter. And this was a case where they intersected in an infinite number of locations or points. And my third system, graphing those lines, there was my first line and my second line. Notice that these two lines are parallel. They do not intersect. Any point that is a solution on one of them is not a solution on the other one. Sketching our no solution system. And finally, let's take a look at word problems. The key thing with word problems is identifying your variables. Your variable is the information that you don't know from the problem. It's the information that you're curious about or that you want to solve for. We have an example here where Angie and Kenny are both buying software packages and paying for months of gameplay. What we don't know is how much the software costs or how much the games cost. So I'm going to let W equal the cost of the software. When you are defining your variables, you need to be very specific. So you couldn't just let W equal software. What about the software? How much they purchased, how much it cost. So be very specific with your variables. The other thing we don't know is how much the games cost per month. If we were going to solve this system, which we're not just yet, we'll learn how to solve systems later, then this is the information that we would want to find from this question. We're going to write two equations. The first equation will be for what Angie purchased. Angie purchased one software package times the cost of the software. In addition, she paid for 3 months of games, and her total was $65. Kenny's was very similar. He also purchased one software package plus 2 months of games, and his total cost was $50. Again, we're going to learn how to solve these later. Right now, we're just practicing getting the equations down. One last example. Two pieces of information that we don't know or that we might be curious about in this situation is how many classes each person takes per month. Once we know that information, we could use it to figure out the total cost that they pay to the gym. There are two different types of people that use this fitness center. We have members. So the total cost, if you are a member, would be that $20 fee that you pay no matter what, plus the discounted rate of $3 times the number of aerobics classes that you take each month. If you are a non-member, your total cost, you do not owe them a fee for being a member, but you do have to pay a little bit more, $5 times the number of aerobics classes you choose to take. You've got two U-Try questions. The first one, use Desmos to get a sketch of what this graph looks like and determine how many solutions it has. The second one, the word problem. If all you can do is define the variables, that's a step in the right direction. This is the first day we've looked at word problems. Do your best to try and set up the system of equations. If you just can't get it on your own, we'll have some time to work with group mates in class and bounce ideas off of each other.